Senior High School On-Air Academy. Unstoppable! Delivering you quality education amidst pandemic.
To defend school opening to October 5.
Unstoppable!
Giving you accessible learning platform anytime, anywhere.
Ang klase, whatever form it is.
Comprehensible!
Buckle up and get yourself ready.
I will repeat, then you will do it later on.
Accurate!
The sphere that includes all living things.
Today, we will be talking about rational functions.
Simplify.
This is Jaw speaking. How may I help you?
This is the School Radio's Senior High School On-Air Academy.
And now, here's your new episode for Numbered Ranks. Your guide for the subject is Statistics and Probability. Numbered Ranks.
Numbered ranks.
Good day, young statisticians! Welcome to our radio-based instruction for statistics and probability. Your calculation, your solving skill. I hope you're having a wonderful day. I am Hensley R. Marquez, your teacher buddy on air. So stay tuned and let's get started. Just a reminder, dear learners, before we start, make sure that you are in your most comfortable place to study. Since you have learned to identify the appropriate test statistic when the population variance is known or unknown, and yet already know how to choose the test statistic applicable in hypothesis testing, you are now equipped to identify the appropriate rejection region when population variance is known or unknown. Can you give me a loud hooray if you're ready to begin? Class, do you want to know what a rejection region is?
Oh yeah!
If you do, buckle up because we shall start your statistics and probability journey after this break.
Wow! Adobong manok! Ang sarap naman ng ulam namin! Ang bango pa! Kainan na!
Hep hep hep! Buknoy! May nakalimutan ka ata!
Ha? Wala kuya! Gutom na po ako kaya kumain na po tayo!
Buknoy! Nakalimutan mong maghugas ng kamay. Lagi mong tatandaan, bago kumain, ugaliin nating maghugas ng kamay. Ang wastong paghuhugas ng kamay ay isang epektibong paraan upang matanggal ang bakterya at germs na lumikit sa ating mga kamay. Ito ay makatutulong upang maiwasan natin ang pagkalat ng sakit sa ating paligid.
Sige po kuya, uugaliin ko na po ang wastong paghuhugas ng aking kamay bago kumain. Kainan na!
Ang kalusugan ay kayamanan, isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
And we are back, learners! I hope everyone is ready and excited to learn because we are about to explore new ideas and knowledge in the world of statistics and probability. Our lesson for today's episode will focus on 2 points. 1. Define the critical values, level of significance, hypothesis test, and rejection region. And 2. Identify the critical value when population variance is known or unknown. Hence, you will be able to determine the appropriate rejection region for a given level of significance when population is known or unknown, and central limit test is to be used.
Okay!
In hypothesis testing, a researcher collects sample data. From the given data, the researcher formulates the null and alternative hypothesis. Then, she or he chooses appropriate test statistic and computes it. A researcher can also accept the null hypothesis given a specific range of values. The range of values that leads the researcher to reject the null hypothesis is called region of rejection. Did you get the idea, dear learners?
Oh yeah!
Let's go over to the important concept of critical regions or rejection regions. How do we describe critical regions or rejection region, learners? Certainly, critical region, also known as the rejection region, describes the entire area of values that indicates you to reject the null hypothesis. In other words, the critical region is the area encompassed by the values not included in the acceptance region. It is the area of the tails of the distribution. Moreover, the tails of a test are the values outside of the critical values. Now, let us recall some concepts that will lead you to the concept of rejection region. Are you ready?
Alright!
Okay, let's begin. Alright, in hypothesis testing, how do we define critical value, learners? Precisely! A critical value is a point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. Critical values for a test of hypothesis depend upon the test statistic, which is specific to the type of the test and significance level, or alpha, which defines the sensitivity of the test. A value of alpha is equal to 0.05 implies that the null hypothesis is rejected 5% of the time when it is in fact true. In practice, the common values of alpha are 0.1, 0.05, and 0.01. Did you understand, learners?
Oh yeah!
Next is the critical value of z or z-score. When do we use it, learners? Absolutely! A critical value of z or z-score is used when the sampling distribution is normal or close to normal. Z-scores are used when the population standard deviation is known or when you have larger sample sizes, while t-test is used when there are small sizes. Also, indicate whether the given standard deviation is for population or sample. If the test statistic is t-test, definitely you have to use the t-distribution. There you go! Another one is the critical value of t-distribution. The t-distribution table values are critical values of the t-distribution. The column header is the t-distribution probabilities, or alpha. The row names are the degrees of freedom, denoted by BF. How do we find the critical values for t-distribution, learners? Indeed, to find the critical values for t-distribution, number 1, identify the level of significance. Number 2, identify the degrees of freedom. BF is equal to n minus 1. And number 3, find the critical value using t-distribution in the row with n minus 1 degrees of freedom. If the hypothesis test is left-tailed, use a one-tailed column with a negative sign. If the hypothesis test is right-tailed, use a one-tailed column with a positive sign. And if the hypothesis test is two-tailed, use two tails column with a negative and a positive sign. Can you still follow me, learners?
Okay!
Class, let's have a run through to the main ideas of identifying the rejection region if population variance is known or unknown and central limit test is to be used. Okay, let's begin. Let us consider the problem when population variance is known and answer the questions that follow. Here we go. The father of a senior high school student is listing down the expenses he will incur when he sends his daughter to the university. At the university where he wants his daughter to study, he hears that the average tuition fee is at least 20,000 pesos per semester. He wants to do a test of hypothesis. Suppose, from a simple random sample of 16 students, a sample mean of 19,750 pesos was obtained. Further, the variable of interest, which is the tuition fee in the university, is said to be normally distributed, with an assumed population variance equal to 160,000 pesos and level of significance alpha is equal to 5% or 0.05. Question number 1. What is the appropriate null hypothesis? Indeed, the average tuition fee in the targeted university is at least 20,000 pesos. In symbols, mu is greater than or equal to 20,000 pesos. Let's proceed to question number 2. What will be the appropriate alternative hypothesis? Certainly, the average tuition fee in the targeted university is less than 20,000 pesos. In symbols, mu is less than 20,000 pesos. How about question number 3? What do you think is the level of significance? Absolutely. The answer is alpha is equal to 5% or 0.05. Next is question number 4. What kind of test will be used? Certainly, it is one-tailed test. Let's move on to question number 5. What will be the appropriate test statistic to be used? Exactly. The appropriate statistic to be used is z-test, since the population variance is known, even though our number of samples is less than 30, or more than or equal to 30 samples, and we will be using the z-table as our critical or tabular value. Thus, the formula will be z sub c is equal to x bar minus mu sub o over sigma divided by square root of n, where x bar and sigma are the sample mean and population standard deviation respectively, computed from a simple random of n observations, and mu sub o is the hypothesized value of the parameter. Let's proceed to question number 6. What is the tabular value of the level of significance or alpha? Precisely. Since the level of significance alpha is equal to 0.05, its tabular value from the z-table is negative 1.645. Moreover, this is a left-tailed test, so the critical value we need is negative, and the rejection region is z is less than negative 1.645. Lastly, as a consequence of the decision, conclusions are made which are in relation to the purpose of the test of hypothesis. With the rejection of the null hypothesis, we will accept the alternative hypothesis. Therefore, the father can say that the average tuition fee in the university where he wants his daughter to study is less than 20,000 pesos. Did you have fun, learners?
Oh yeah!
Alright, now let us determine when population variance is unknown. Here's the problem. The father of a senior high school student lists down the expenses he will incur when he sends his daughter to the university where he wants her to study. He hypothesizes that the average tuition fee is at least 20,000 pesos per semester. He knows the variable of interest, which is the tuition fee, is measured at least in the interval scale or specifically in the ratio scale. He assumes that the variable of interest follows the normal distribution, but the population mean is known. That is 20,000 pesos. The father asks, at random, 25 students at the university about their tuition fee per semester. He is able to get an average of 20,050 pesos with a standard deviation of 500 pesos. Suppose the level of significance alpha is a set of 0.05. In order to solve this, first, let us formulate the null and alternative hypotheses. What are the hypotheses, learners? Very good! Null hypothesis is the average tuition fee in the targeted university is at least 20,000 pesos. In symbol, mu is greater than or equal to 20,000 pesos, while alternative hypothesis is the average tuition fee in the targeted university is less than 20,000 pesos. In symbols, mu is less than 20,000 pesos. Secondly, identify the test statistic to use. What test statistic to be used, learners? Certainly, since the population variance is unknown and the number of samples is less than 30, then we will be using t-test or the test statistic t sub c is equal to x bar minus mu sub o over s divided by square root of n, where x bar and s are the sample mean and sample standard deviation respectively, computed from a simple random of n observations, and mu sub o is the hypothesized value of the parameter and follows the student's t distribution with n-1 degrees of freedom, which means the tabular value in the student's t table will be used as a critical or tabular value. Third, let's compute the value of the test statistic. What will be the value of the computed test statistic? Certainly, by applying the formula t sub c is equal to sample mean minus hypothesized value of the parameter over sample standard deviation divided by the square root of sample size. From the given data gathered, sample mean or x bar is equal to 20,050 pesos, population mean or mu is equal to 20,000 pesos, sample standard deviation or S is equal to 500. Sample size or N is equal to 25. And degrees of freedom N-1 is equal to 24. Hence, the computed test statistic is T sub C is equal to 0.5. Thus, negative T sub C is equal to negative 0.5. Fourth, make a decision rule. What do you think is the appropriate decision rule? Indeed, the decision rule can be one of the following possibilities. 1. Reject the null hypothesis. If the computed value of test statistic denoted by T sub C is less than its tabular value or critical value from T table, which is negative T sub alpha and N-1. Otherwise, we fail to reject null hypothesis. 2. Reject the null hypothesis. If the computed value of test statistic T sub C is greater than its tabular value or critical value from T table, which is negative T sub alpha and N-1. Otherwise, we fail to reject null hypothesis. 3. Reject the null hypothesis if the absolute value of the calculated statistic T sub C has a value less than the critical value or tabular value from the T table, T sub alpha over 2 and N-1. Otherwise, we fail to reject null hypothesis. Meanwhile, the level of significance alpha is equal to 0.05 and its tabular value from the T table is negative 2.064. With the computed value of the test statistic, T sub C is equal to negative 0.5 and its tabular value or critical value from T table, which is negative T sub alpha, is equal to negative 2.064. By means of the decision rule, reject the null hypothesis. If the computed value of test statistic T sub C is less than its tabular value or critical value from T table, which is negative T sub alpha and N-1, otherwise we fail to reject null hypothesis. Since negative 0.5 is greater than negative 2.064, the rule dictates that our decision is not to reject or fail to reject the null hypothesis. Moreover, this is a left-tailed test, so the critical value we need is negative, and the rejection region is T is less than negative 2.064. Lastly, we state the conclusion. How do we state the conclusion, learners? Exactly. Therefore, the father can say that the average tuition fee in the university where he wants his daughter to study is at least 20,000 pesos. Did you have fun in the activity?
Oh yeah!
Nice job! Now, let us try to determine the critical values and the appropriate rejection region of the following problems. You will need a separate sheet of paper for your computation. I'll be reading the problems. Start answering. You are given 20 seconds for each item. Number 1. Right-tailed test where population variance or sigma squared is known. Alpha is equal to 0.05 and sample size or N is equal to 34. What is the critical value and its appropriate rejection region? Number 2. Two-tailed test where population variance or sigma squared is unknown. Alpha is equal to 0.05 and n or sample size is equal to 10. Find the critical values and their appropriate rejection regions. Alright, ballpens up, check your papers honestly. Here are the answers. For number 1, in this problem, the population standard deviation is known. Therefore, the test statistic would be z-test. To obtain the critical value for the level of significance of 0.05 and one-tailed test, z-value from the table is 1.645. The hypothesis test is right-tailed, so the inequality symbol would be greater than or equal to. Hence, the rejection region for one-tailed test is z is greater than or equal to 1.645. For number 2, since this is a two-tailed test, 1/2 of 0.05 is equal to 0.025 of the values would be in the left and the other 0.025 would be in the right tail. Looking up t-score, degrees of freedom, n is equal to 10 minus 1 is equal to 9, associated with 0.025 on the reference table. We find 2.262. Therefore, positive 2.262 is the critical value of the right tail, and negative 2.262 is the critical value of the left tail. The rejection region is t is lesser than or equal to negative 2.262 but greater than or equal to 2.262. Did you find the activity great, learners?
Oh yeah!
Alright, I know you're ready for the quiz. However, let's have a short recall identifying the appropriate rejection regions for a given level of significance when population is known and or unknown, and central limit test is to be used. Can you describe rejection region? Very good! It describes the entire area of values that indicates you to reject the null hypothesis. Also, it defines as the area encompassed by the values not included in the acceptance region. It is the area of the tails of the distribution. Moreover, the tails of the test are values outside of the critical values.
Okay!
Well and good, rock and roll. Be prepared because after this infomercial, you'll have your quiz right away.
Happy birthday to you! Happy birthday, happy birthday, happy birthday to you! Ngayon ba ang kaarawan mo? Hindi! Hinuhugasan ko lamang ng mabuti ang aking kamay. Sabi ng DOH, 2 happy birthday songs daw upang makaiwas tayo sa COVID-19. Wow! Ang galing naman! Simula ngayon, maghuhugas na ako ng kamay habang umaawit ng happy birthday. Ang inyong kalinisan at disiplina ang magliligtas sa inyo. Isang paalala mula sa DOH, DepEd at ng himpilang ito.
Congratulations! With that, here is a quiz. Consider the given situation. Let me read the following problems. A brand of powdered milk is advertised as having a net weight of 250 grams. A curious consumer obtained the net weight of 10 randomly selected cans. The values obtained as the sample mean is 248.2 and its standard deviation is 4.614. Is there reason to believe that the average weight of the powdered milk cans is less than 200 grams at 5% level of significance? Assume the net weight is normally distributed with a known population variance. Number 1. What are the hypotheses? Number 2. Is it a two-tailed or one-tailed test? Number 3. What is the level of significance? Number 4. What appropriate test statistic, z-test or t-test, can you use? Number 5. What is the tabular value of the alpha? Number 6. What is the value of the computed test statistic? Number 7. What would be the decision based on the computed test statistic? And 8. Based on the decision, what is the appropriate conclusion? And that's the end of our quiz for today. We are going to reveal the answers in the next episode. The script for this episode was written by Hensley R. Marcus. This has been your radio teacher, Hensley R. Marcus, now signing off.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!